So this is a third order, yeah? And the rule is, you know that a cubed minus b cubed factoring, true? Let's write it in green. We know that a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Yeah? And here when you do the characteristic equation, you will get r cubed minus 8 equals 0. So you could use that to factor it. You agree? And when you, so this is the same thing as saying r cubed minus 2 cubed, because 2 cubed is 8. Equals 0. So your a is r, and your b is 2. So, you know, just plug it into the factoring thing. So you get factoring equation. So you get r minus 2 times a squared, which is r squared, plus 2r plus 4 equals 0. Okay? And we know that this is a polynomial of degree 3, so we know that there will be 3 roots. So the first one is as expected, r minus 2 equals 0, which will get you r equals 2. But then you also have to solve this one. And this one will have complex conjugates. It's not going to have reals. That's why you can't see it right away. And that's what I was talking about, de Moivre's theorem and trick.
Oh,
De Moivre. Remember de Moivre?
I remember de Moivre.
Yeah, so that's the one.
Yeah.
Say hi to him. No, so r squared plus 2r plus 4 equals 0. You can't factor this, so you use the quadratic formula, right?
Yes.
The quadratic formula says minus b plus or minus square root b squared minus 4ac all over 2a. Okay? Start writing, man, because this problem will take a while because we have 3 boundary conditions. Okay, so now we can solve for r. So r is minus 2 plus or minus square root b squared is 4 minus 4 times ac, 1 times 4, all over 2. So we will get minus 2 plus or minus. 4 times 4 is 16. 4 minus 16 is square root 12, all over 2. Square root 12, I could rewrite it as minus 2 plus or minus 2 root 3 all over 2. So factor out the 2, so you'll get minus 1 plus or minus root 3. Oh, I forgot the I. Of course, there's an I, because you get a minus 12 here, so which puts an I outside. So minus 1 plus or minus root 3i. And so then we will get 3 different roots. So we have 2, we have minus 1 plus root 3i, and we have minus 1 minus root 3i. Okay, and now what we will do is write down the general solution. So the first root gets you an exponential, 2, is this an x? Yeah, let's just say it's an x. So 2x plus the second 2 will get you an exponential in addition to a sine and cosine. So you would get e to the minus x, because the real part of the root corresponds to the exponential power, and the complex part of the, or the imaginary part of the complex root corresponds to the coefficient of the x sitting inside the sine and cosine. So this will be c2 cosine root 3. Let's actually call them a, b, and c, might be easier, the coefficients. A, b root 3x plus c sine root 3y, root 3x. So this is the general equation. Now we will use the boundary conditions and or initial conditions to solve for the roots. What happened here? This one is B. Okay. There we go. So now we are told that y of 0 equals 0. So let's start plugging those in. So y of 0 equals 0. That means when x equals 0, y equals 0. So we get a plus cosine 0 is 1. We got the x here. Okay. Cosine 0 is 1, so we get b, and sine 0 is 0. So a plus b equals 0. So that's the first equation. Now, we are told that we're given information on y prime and where is it? Y double prime. So let's go ahead and find what y prime and y double prime is. Yeah, and this might take a bit because of the product rule in the derivative. So let's do y prime here. So far we have one equation. So we know that y prime will equal 2a e to the 2x. Here I will do the product rule. So minus derivative of the first is minus e to the minus x times the second as is. So b cosine root 3x plus c sine root 3x. Okay. And then plus the first times the derivative of the second. So plus e to the minus x times the derivative of this will be cosine is sine, so minus b sine root 3x times the derivative of the inside, which is root 3. And sine is cosine, so this becomes c cosine root 3x times the derivative of the inside, which is root 3. So this is y prime. And now we can find so we are told that y prime of 0 is 1. Let's do the double derivative first. So y double prime. So this becomes 4a e to the 2x plus. Now, this will require probably be easier to just factor out so I don't have to do the product rule twice. Probably easier to factor out e to the minus x. Yeah? So you don't have to do the product rule twice. So why don't we do that first? So y prime is 2a e to the 2x minus e to the minus x times b cosine root 3x plus c sine root 3x. So that's from the first one. And from the second one, there'll be a minus because there's a plus here. So minus minus will make it a plus. So minus. So that's minus. So that's plus b root 3 sine root 3x minus, because there's a plus here. So it turns into a plus with the minus sign outside. So that's c root 3 cosine root 3x. Okay, so then y double prime will be, the first one is straightforward, 4a e to the 2x. Now the product rule here, so probably easier, it's probably going to take me 2 lines. So derivative of e to the minus x is a minus e to the minus x, but there's a minus here, so this becomes a plus times this whole thing as is. So I won't rewrite it, I'll just bring it down.
It's not repeating
No, it's not repeating, they're different.
Right. Yeah, the negative 1 plus the negative
yeah, it's minus 1 plus root 3i and minus 1 minus root 3i.
Yeah.
Actually, let me just write it down here. So this is b cosine root 3x plus c sine root 3x plus root 3b sine root 3x minus root 3c cosine root 3x. Okay, so that's the first part of the product rule. Plus minus, let me start here. So minus, so I'm continuing down here. E to the minus x, the first as is, times the derivative of this whole inside now. So start with this. So this is going to be b minus sine root 3x. Then the chain rule on the inside will get me a root 3. So this becomes root 3b sine root 3x. And then on the second one, it's same thing, root 3 except cosine and plus. So root 3c sine root 3x plus, now sine becomes cosine root 3x root 3b times the derivative of root 3x, which is root 3, so root 3 times root 3 becomes a 3b. And then here cosine is minus sign, and there's already a minus, so this turns into a plus 3c sine root 3x. So that is y double prime. So now,
for the when you just got the y.
yeah,
Uh,
this is the y. Yeah, make sure the y is correct because this is a long derivative. You have the real part of the root will be the power of the exponential.
And this would be sine, and that would be the cosine. It wouldn't be sine, cosine of both.
No, it doesn't matter. It's just the root 3 goes into the sine and cosine.
All right, so there's not like sine and cosine of positive, and sine of cosine of negative.
It's already absorbed into your
That's why
constants.
that's why the cosine is there, because it's
Right.
odd function.
All right.
Even function.
Yeah. So now we know that, where are we here? We know that y prime of 0, the initial condition is y prime of 0 equals 1. So let's make use of that. So y prime of 0 equals 1. So when x equals 0 and y prime, we will plug in 0 and for x and y prime, we get 2a minus, so b, because cosine 0 is 1. The signs will go away because sine 0 is 0, minus root 3c. And that has to equal 1. So this is equation number 2. And then equation number 3, we are told that y double prime of 0 is 0. So we will plug in 0 in the y double prime for x. So we get 4a plus, now all the signs will go away and the cosines will survive because cosine 0 is 1, sine 0 is 0. So we get b plus or minus root 3c minus e to the 0 is 1, so just minus 1. And then the signs go away, and then we get 3b. Wait, I'm suspecting there's something wrong here because we're supposed to get, so this cosine gets us a sine, this gets us a cosine. Oh yeah, this is a cosine, not a sine here. So let me fix that. So this is a cosine with dx. Okay, so continuing with this. So we have 3b plus root 3c equals 0. And this is equation 3. And we've already had equation 1 that said a plus b equals 0. This was equation 1, meaning a equals minus b. Right? So let's call, okay, let's keep this as is. Now notice that if we add equation 2 and 3, those two go away. So I'm going to add equation 2 plus equation 3 just to simplify this. So from here we get 2a plus 4a is 6a. These go away. Minus 3b minus, I will FOIL the minus sign, so root 3c equals 1. Okay, and I already know that a equals minus b. So that means I can replace b with minus a. So we would get 6a plus 3a minus root 3c equals 1, which makes 9a minus root 3c equals 1. So that's another equation, right? And since equation 2 is simpler than equation 3, I will take this and equation 2 and solve them. So we will get, so now equation 2 becomes, let's change the color here. So let's call this equation 1, 2, 3. Where are we on the count? 3, 4. Let's call this equation 4. So I will take now equation 1. I will take equation 1 and f2a, since I have a, I will keep a, so 2a minus b, but minus b is a, so this becomes plus a plus root 3c equals 1, which means 3a plus root 3c equals 1, and I already know that from equation 4, so I'll just rewrite equation 4 here, 9a minus root 3c equals 1, and you can see if I can just add these two, it works out nicely because those go away, the root 3c and the minus root 3c. So we get 12a equals 2. And finally, we got one of them. A is 2 over 12 or 1 over 6. So that's A. And B is just negative that. So B is just minus 1 over 6. And then to find C, I could just plug this into either equation. Why don't I just use 3a plus this one right here? Probably the easier one. So 3a, so I'm going to plug in a there. So 3 times 1 over 6 plus root 3c equals 1. So that means root 3c equals 3 over 6 is 1/2. 1 minus 1/2 is a half, which makes c equals 1 over 2 root 3. There we go. We solved for all our constants. And now we're going to take a, b, c, and we are going to plug them into the blue boxed equation. Did you get to any of your constants, man, or not yet?
I got y 0 c2 plus c3 and 0 and y prime is negative square root 3c1 plus 2c3 is 1. Now,
So y equals a e to the 2x, and a turned out to be 1 over 6. So 1 over 6 e to the 2x plus e to the minus x times b, which is minus 1 over 6, cosine root 3x. So we substituted minus 1 over 6 for b, and then plus 1 over 2 root 3 sine root 3x. And this would be the final solution of our third order homogeneous differential equation with constant coefficients, with all the constants and the coefficients determined.